Hello everyone, welcome back to our channel. So today we are going to solve some questions related to K-Nearest Neighbours or the KNN algorithm in machine learning. Okay, so let's get started. So this is the first question that we are going to solve. Let's see what they are asking us. Consider a set of 5 training examples given as xi, yi, ci values, where xi and yi are 2 attributes or positive integers and ci is a binary class label. Okay, so they are saying that xi and yi are attributes. Attributes are also called features. So they are saying we have 5 data points with xi and yi as features, and they are saying there is class ci associated with this, which is a binary class. Okay, let's look at the points. So this is the first point, this is the second point, this is the third point, fourth and fifth point. So xi is 1 here, yi is 1, and the class label ci is -1. Similarly, they have given us 5 data points. What they are asking is classify a test example at coordinate 3, 6. So they are saying that the xi value for the test point is 3, 6, and we have to use a KNN classifier where k is equals to 3. So we have to use a 3NN classifier, and Manhattan distance is divided by defined by d. This metric has given. So they have also given us a distance metric. So in case they are not giving the distance metric, we usually take the Euclidean distance as the distance metric, but here they have given us the Manhattan distance, so we'll use this. Okay, so let's solve this question. So first let's understand what is a KNN classifier in brief. So a KNN classifier is a very simple classifier in machine learning domain. So first of all, it's a lazy classifier. When I say lazy classifier, it means that there is no training involved, or the computation is postponed till you actually have to predict. Postponed compute. Okay, and why does that happen? That the compute is happened. The compute is postponed till a test point is given. Till test, because there is no learning, so there are no parameters for this. So there are no parameters that are learned. So for example, in all the other algorithms like linear regression or a neural network, there are some weights and biases that you learn. In linear regression, you learn some again you learn some weights, but here there are no parameters involved. Your training data is learned as it is. So your training data, whatever is given, is your model, is the model. Okay, and what you do is you just memorize this. You memorize whatever data you had in training. At test time, while testing, find K-nearest neighbours of test point and label it. Okay, so what I mean is, suppose you are doing a classification problem. You have, suppose that you have these data points. You have 3 cross and a positive. Okay, and you are doing 5 nearest neighbors, and so you are doing a 5 nearest neighbors, and you have a data point here. Okay, this is your data point. So this comes. So what you'll do is you'll find 5 nearest neighbors of this, and you will take the max vote. So whatever is the majority saying, we will take the max vote. So majority of them are crosses. So this is the predicted label. There was a very good question asked in comments in one of the previous videos, which was like that sometimes what happens is, if say we had been given 4NN. Okay, I'll do this here. Suppose you had a data set like this. Okay, and your test point was like this. Okay, and actually this. Suppose this was your data set and you were doing a 4NN, okay, and your data point is this. So here you have 2 positive labels and 2 negative labels, so you are in a tie, right? You are in a tie. So here usually we take the K to be odd to avoid such ties. Okay, so K is mostly taken to be odd so that we can avoid such ties. But even if somebody asks you 4NN, they will specify how to break the tie. For example, they can say that if there is a tie, you can randomly select 3 of them and vote. Or you can take one more data point. Suppose one more data point you can consider. So maybe then you can consider 5 neighbors and then you can do the max vote. Okay, so if you are being asked a question in gate and you see there is a tie happening, they will specify, most definitely they will specify how to break the ties. Some of the most common ways to break ties is take a random set of values and predict, or you take one more neighbor and predict. But you should be specified to make the question less ambiguous. They'll specify what exact metric you have to take to break the ties. Okay. So KNN is also used in regression setting. So we talked about the classification setting. Now let's talk about the regression setting. Suppose that you have data points like this. Okay. And you have data points like this, okay, and a new data comes in. Suppose that this data comes in, okay, and this is your prediction data. So in regression also what we'll do is we'll find K-nearest neighbors and then we'll take some metric, and metric is usually median or average of the values. For example, if we are doing 3NN here, say 3NN we have to do. So we'll take these 3 data points and we'll take the average point of this and we'll predict. Okay, we'll predict the average of this. So this is how KNN is used in regression setting. This is how we use it in classification setting. Now let's come back to the question and try to solve this. Okay, so they have specified that we have to use 3 neighbors and we have to use the Manhattan distance. Fine. So let's first compute the Manhattan distance of our test point. So our test point is 3, 6. Let's compute the Manhattan distance of this test point with every other point that we have. Okay. So how are we going to compute? So it says that you have to take the absolute difference between the x feature and the absolute difference between the y feature, and you have to add it up. Okay, so it will be like 1 minus 3 absolute plus 1 minus 6. Okay, so this is minus 2, my absolute value of minus 2 plus 1 minus 6 is minus 5. This is the absolute value of minus 5. So this is equals to 7. Okay, now let's take the second example and take the absolute value. So this is 1 minus 3. 1 minus 3 plus 7 minus 6. You have to take the absolute value. So you have to take absolute value of minus 2 plus, this is actually inequality, then you have to take this. So absolute value of minus 2 is 2 and this is 1. So this is 3. Okay. Now you have to take, you have to do 3 minus 3, subtract the x feature and now subtract the y feature. So you have to do 3 minus 6. Because we are taking the absolute value, the order doesn't matter. So this gives us 0, absolute value of 0 plus absolute value of minus 3, which is equals to 3. Okay. Now we are doing the fourth example. So we have to do 3 minus 5 plus 6 minus 4. I reversed the order by mistake in this, but it doesn't matter because we are taking the absolute value. So this will be minus 2, absolute value of minus 2 plus absolute value of 2, which is equals to 4. Then you have to take the absolute value from this. So this is 2 minus 3 plus 5 minus 6 absolute value, and this is absolute value of minus 1 plus absolute value of minus 1, which is equals to 2, right? Now we have to find the nearest neighbors. So nearest neighbors are being found from the metric, which is distance metric. So you will find what all 3 samples have the lowest Manhattan distance from this sample. Okay, so we can see that sample 2, sample 3 and sample 5 have the lowest distance. 3, 3, 2, 4 and 7 are greater. So these are the 3 points which are nearest to this test sample. Now look at the classes for this. So this is a positive sample, right? So here it's a positive class. So this is the negative class. So this is negative and then this is negative. Okay. Now because this is a classification problem, we'll do a max vote. So we'll take this 3 and we'll take the max vote, and which is, so we have 2 negatives, 1 positive. So our predicted label will be negative. Understood? 7, 3, 3, 2, 5. Oh, sorry, I made a mistake over here. This is a positive sample. So this is a positive sample. So this is actually positive. I made a mistake. So third sample is positive, second sample is positive, and fifth sample is negative. I actually took this by mistake. Let me correct this here. Yeah, sorry about that. So second sample is so these are the 3 samples which are closest. So second sample is positive, then the third sample is positive, and the fifth sample is negative. If you take the max vote of it, this is positive, right? So the solution is positive, right? So the nearest neighbors are 1, 7, 3, 3 and 2, 5, and the majority class is positive. So this is how we solve this question. These kind of questions can be asked very easily in GATE. If they don't define the metric for distance, you can use the Euclidean matrix. Fine. Okay. Let's move on to the next question. So this is a true-false question. They are asking, as the value of k used in KNN classifier, is incrementally increased from 1 to n, the total number of training examples. So basically n is the total number of training examples. So total training examples. Total number of training examples. The classification accuracy on the training set will always increase. Okay. So they are asking that if we have to tell whether if I keep on increasing the value of k from 1 to n, where n is the number of training examples, accuracy on training set will always increase. Okay. As the value of k used in KNN classifier is incrementally increased from 1 to n, the total number of training examples, the classification accuracy on the training set will always increase. Fine. Okay, so this is a good question. So let's understand the classification accuracy on training set. Okay, so let's take a very toy example over here. Suppose this is my data set. Okay, fine. So now let me use a one neighbor classifier here and try to classify it. And I'm doing it on training set. Fine. So when I use the training set, all of these examples are already available in the training, right? So whenever I pick a data set or data point from this, it will be classified correctly, right? So this is little tricky to understand, but let me explain it again. So because KNN, it does is it memorizes the training set, right? So when I am calculating the training accuracy, what I'll do is I'll take one example from the training set and I'll try to classify it using the KNN classifier, which happens to be 1NN here. But because that data point was already in training, it will be classified correctly, right? Now let me take the 2NN over here, right? So in 2NN, what I'll do is I will take two nearest neighbors, and then try to classify it. Okay. So for example, when I'm classifying this point, for example this point, right? So I can take any two neighbors here. All of them are positive, right? So even if we get into a tie, I can randomly select two neighbors, and this negative point will actually be classified as positive, right? So we contradicted that, okay, 1NN had 100% accuracy, right? But 2NN, we can clearly see that one of the point is getting misclassified, right? Let's do a 3NN as well, because I said that we usually don't take 2NN or even number of NNs. Let's take 3NN. So I'll do it on the next slide. So this is my data set. This is my data set, right? And I'm trying to do a 3NN classifier. Okay, so all this has already been memorized by my model. Now let's suppose I give this plus as the data set again. Okay, so we'll look at three nearest neighbors of this. So this is one neighbor will be itself, the second neighbor will be here or here, and one of the neighbors is here, right? So we are getting in a tie, but we can choose. So this is the nearest. These two are at equal distance. We can take any one. So we'll take, for example, this, and this, right? And I'll do a max vote. When I do a max vote, this positive example gets classified as positive, right? So this A, for example, I'll name these C, D, E. A basically gets classified positive. Now let me take D. Sorry, this is E. So I'll take the E sample, right? I have to take 3 nearest neighbors of this. So all of them are equal distance and all of them have the same label. No matter what I choose, all of them have positive label. So suppose I choose A, B, C. Maybe the tie rule that has been given in the question is that take the lowest alphabets if there are ties. So I take A, B, C, and they are positive, 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 positive. So max vote is positive, right? So my accuracy is basically decreasing, right? So this statement where it's saying that if I increase K from 1 to n, the number of training examples accuracy on training set will always increase. We just proved that that's not true. This is false. Okay, so this is false.